For number 33, in trying to solve for theta, we know that when the tangent of something is equal to 1, that something has to either be that pi over 4, or, because the tangent is positive in both the first and third quadrants, the other spot on the unit circle, the only other angle in the unit circle where the tangent is 1 would be 5 pi over 4. So no matter what, that thing has to either be equal to pi over 4 or 5 pi over 4. So let's go ahead and replace that that space here with what actually is inside the parentheses. That's theta over 2 plus pi over 3. So since theta over 2 plus pi over 3 must be equal to pi over 4 or 5 pi over 4, we're going to go ahead and set up two equations again, just like the last problem. Theta over 2 plus pi over 3 must be equal to either pi over 4 or theta over 2 plus pi over 3 would be equal to 5 pi over 4. And then when we solve this equation here, we're going to subtract, let's do this down here actually, because it's running out of room down there, over there. Theta over 2, we're going to subtract pi over 3 from both sides. In both of these equations, so I'll write the result down here. First equation becomes theta over 2 is equal to pi over 4 minus pi over 3. And then the other equation is, second equation here is theta over 2 equals 5 pi over 4 minus pi over 3. So let's see what we do here. We need a common denominator, so this would be 3 pi over 12 minus 4 pi over 12, which would give us negative pi over 12. So we end up getting theta over 2 is equal to negative pi over 12. And over here, this would be 15 pi over 12. So we're multiplying top and bottom by 3. And then in the second fraction, we're multiplying top and bottom by 4. So we end up getting theta over 2 is equal to 15 pi over 12 minus 4 pi over 12, which gives us 11 pi over 12. And then we can see we need to multiply both sides by 2 to get the theta by itself. And then getting the theta by itself on the left is good. The 2 goes into 12 6 times. And so on the right-hand side, we get negative pi over 6. Well, that's outside the interval from 0 to 2 pi. So since it's outside the interval from 0 to 2 pi, we would just call that an extraneous solution. We're not going to list that, even though when we replaced theta with that angle, it would make the equation true, but it's not one of the angles we're looking for. On the other hand, if we multiply both sides of the second equation by 2, we get theta is equal to 11 pi over 6, and that certainly is between 0 and 2 pi, so therefore that would be our only solution. And that's it.